Okay, so we will see in today's class. Basically, we will be going with the assembly language programming. So basics of assembly language programming. So in assembly language programming, we will be taking the help of us software. So that software will be the Keil software. So Keil software, just search on uh, the Google. You will be having this link. Click here. By clicking there, you need to click on downloads, and there are different types of products available based on our requirement. So if you want to uh, write assembly language programming for cortex or arm type of different devices, you need to download this one. Or if you want to write assembly language programming for 8051 type of devices, this is are the basic microcontrollers, then you need to download this one. And similarly, there are different products based on different type of devices. So basically we will be going with the 8051 device programming in terms of assembly language programming, because these 8051 are basic microcontrollers that are most frequently used in case of any projects you are going to implement with respect to microcontrollers. So we will be seeing this software, installing it, and then working on this in terms of the assembly language programming for 8051. So just click on this, and by clicking this, you need to fill some forms and some details, and then you will be submitting. Then you will get the link for downloading C51. So once it is downloaded, just install it. So normal procedure for installing it is there. Okay, so once you have installed, you will be getting the icon like this. So Keil Microvision 5, you will get the icon this one. So once you want to run the program, you need to click it. So once you click on this program, it will be opening. So once it is opened, so the first thing in this what you need to do is, whatever the previous project is there, that is opened already, you need to first close this project, and you need to create a new project. So whenever you are going to create a new project, you need to close the previous project that is opened. Okay, so go to project section and click on the close project. Okay, so once you have closed the project, your window should be looking like this once you are going to start a new project. So basically, when we are going to do the assembly language programming, we will be creating a project. Into that project, we will be adding different codes separately. Okay, so the code file will be different. uh, so for adding that, before starting, we need to create a project. So go to project and create like a new microvision project. Click on that, and you need to create a folder somewhere in like a D drive. I have created a folder in studies. Inside that, a Keil folder is there. Inside, whatever the project you want to create, whenever you are going to create a particular project, you need to create a separate folders. Because once you create a project, and inside if you run a program, it will be creating different files. So once you run all the programs in same files or same folder, it will be creating a like a mess up. There will be lots of files generated, so you will not be able to identify like which one is of which program. So you need to create a separate file folder for each project. Okay, so suppose we are creating a project called demo. So we have created a project demo, and then you need to give the name. So whatever the project is there, you can give the name similar to that only. Suppose you want to do the add operation, or you want to perform addition, so you can create a project named addition, and then inside the uh, folder, you need to create the file or the project name, also the addition. So that will be easy for you to understand. Okay, so we have created a demo folder, so we will be creating a demo project name also, and then save it. Once you are going to save, it will be asking for what is the target device you want to write the assembly codes for, what particular device. So basically we are going to write for 8051 microcontroller. So these are the different companies that basically fabricate 8051 microcontrollers. Okay, so any of the device you can select, but most frequently it is used is Atmel 89S501. So most frequently it is used like that. So any of the device you can select. Okay, so suppose S51 is there, you can select this one. So once you click a particular device, you will be getting to know like what these are there basically, what are the different properties of that particular device are there. So here 8051 based full static CMOS controller with 3 level program memory, uh, log, 32 input output lines, 2 timer counters, 6 interrupt sources, watchdog timers are there, 2 timer counters are there, 2 data pointers are there, 4 kilobyte flash memory is there, 128 byte of on chip RAM is there. So this is the property of this particular device. Similarly, you can consider click on any other device, you will be getting a separate like a property. So most frequently we will be using like Atmel AT89S51. So you can go with that only. You can take any device. Okay, so the basic programming will be the same in case of 8051 type of devices. Okay, so we have selected that, so we will be selecting. So here it is going to say like copy startup.a51 to project file, so we will be avoiding it, we will not be copying it, no. So now we have created a project. Once we have created a project, here whatever the programs we will be writing, we can write that program in different type of languages. Okay, so either we can write the program in uh, C language, or we can write in assembly language, or in different direct we can write in text format also in the upload area. Okay, so to have that, we can create a separate like uh, options, separate files to add to this group. So once this is the project, in that project we have created a source group. In that source group we will be adding the programs. Once you click there, there is another option is like, so just let's create a program first. So to create a program, you can go to directly into the new, also new section. Okay, so once go to new, it will be creating a text editor type of file it will be creating. You need to save this file. Okay, so just click on the save. So once you will be asking to save, so you can just check, we have created a demo. Inside demo we have created a project demo. Okay, so once we create a project, these two are the files that are created by default. So that's why it is recommended to create a folder, or for which you are going to create a project, so that there will be different files generated that will be saved into this folder only, that will not be like common for all. So it is a good practice to create a folder, inside that you save your project file. So once we have saved the project file, these are the files it has created. And we want to once we have created the project file, we want to create now a file that will be containing the codes. So that containing the codes, we need to give the name. So suppose demo is the name of the project. Similar, you can give the name to the code file also. But if you want to create the code file in terms of C, then its extension will be given like .c, then save it. Or if basically we are going to have assembly language programming, so its extension is ASM. Okay, so whenever we are going to create a code file, we need to save that code file with .asm extension, and then save it. Save inside the your project folder, demo project folder we have created. Inside that only we will be saving the code file. Okay, that .asm. So once we have created this code file, now we will be writing the basic codes. Okay, so in the writing basic codes, suppose basic code is moving content from A to B. Suppose we are going to move the content from uh, A location to B location. So for that, here Basically, backslash are used as a like comments. So here we are going to move content of A to B registered. So to write the code, what we do is our first step is we need to like start with org. So org basically gives command like where our programs will be uh, stored, or from where our program should be starting. So its content we need to give is 00h, or in capital H you can give, or small h is also you can give. So this is basically like we are going to give the location like from where the program should be starting. So from 00 location the program will be stored at 00 location. Origin will be from 00, okay, location. So now we need to move the content. First move the content, what any content, to A. So suppose 10 is the content, 10h is the content we want to move into the uh, A. Similarly move another content B. Okay, initially we are going to move the B. Suppose 20h is there. Okay, but our main motive is to move the content of B into A. So we want to move the content of B to A. So for that there is no need to have a value in A, but I have given value like so that it will be changing it. We will be able to see like how the values are changing. So that's why I have put 10h value into A, and then 20h into B. Now we are going to move the content from B to A. So A should be the destination one, so it should be written first and then B. So this will be moving the content of A and B, B to A, and then finally we need to end the execution. So at the end of the assembly like programming, we need to input the end command. Okay, so we can just give like, if we have written a semicolon, that will also be considered as the comment only. Okay, so here starting address for the course, this will be like moving 10h in A register. Moving 20h in B register. This is moving content of B to A register. We are going to move content of B into A. Okay, and this is to give the end. Okay, so this is the basic program written in .asm file. So we will be saving it. So once we have saved it, now we need to put this code file to this source group, so that it should be included into this project. So because this demo.asm is separately created, it is not attached to this project. So now we need to attach it into the project. So just click on this source and then click on here. Okay, here add new item to source group 1. So we are going to add some new item into this source group 1. We need to click it. Okay, so in that clicking we can click, these are the different file format it basically supports. So it can support .c type or .c++ file also, or .asm file also, some header file or text file or even image file. Different type of files it basically supports. So for that we need to uh, see like how we can add it. So just go to here. So for adding into that, Yes, basically, okay, add new instead of new. Once you go for add new, it will be going to add a new file, but we have created already the .asm file. So if we have created the .asm file, we need to directly add it. So either we can save the asm file as .s or .asm file. Okay, so we can create from there also, select there also, or once we have created demo.asm, we need to add existing file already. So add existing file to the group. So existing file is this one. It will be taking to the same project folder itself. You need to click it here and add, and then close. So once we expand it, it will be is visible like this has been added. Okay, so once it is added, now the first step to run is to build. So go to the project and you need to go to build target. So this is the first step we need to proceed. Or the similar its shortcut is given here also you can just see. So this is translate, and this is build, and this is rebuild. So basically, build is whatever this code we have written in assembly language programming. Once we click on build, what it does is it will be converting this codes into the machine language codes. Okay, and this codes will be understandable to the processor basically, or the machines. So we need to either go to here and build, click on the build. Once we build, it will be showing you some errors. Just okay, so you can just see here there is zero error and zero warnings are there. So there is no error into the program. Okay, and next is we once we have built the program, for checking either there are some errors or not, we will be going to debug. Once we go with the debug, it will be running the debug means running the program basically. Once we click on this debug, start debug, this is the warning because this is an evaluation mode we have installed. We don't have the license version of this software. That's why it is saying that in evaluation mode you have the limit size of 2k. 2k type of 2k size of codes can only be run. So our codes are, most of the codes that we will be doing is that is less than the 2k only. So no problem, it is whatever the warning it is giving. Okay, so now we have reached to the debug section. So in debug section basically we will be running this code one after another. After one line of code, then we will be checking the content. So these are the different registers. So these are inbuilt registers available into this 8051. Internal registers are there, r0 to r7. Similarly, another registers are A and B, and stack pointer registers are there, and its maximum content can be 07. And dptr is data pointers basically, to represent the address locations we use the data pointers. States are there, and psw are basically once we expand it. So psw basically are the flag registers. Okay, so it's like this one is carry, this is called carry, this is auxiliary carry. Okay, and this is reserved, and overflow is there. So these are the different program status. PSW stands for program status word. So status registers we have already known, like flag registers are called status registers. Okay, so when we will be doing some addition and subtraction, we can check the status of the this PSW registers. Okay, so there are different registers that will be changing with based on the execution. So right now this is showing like the execution of the program is at this location, and you can just check the program counter. So program counter content, uh, okay, so just check here, the program counter content is 0000. So once we have put here 00h origin uh, origin basically, so program will be starting with 00 location. That means it is saved at 00 location, this one. Okay, so once we want to run this, you can click on again debug. So there is an option of run. So once we click on F5 or run here, it will be running the code up one after another. It will be running and showing the result. Or there is another option like step, F11 the shortcut, or step is there, like we will be running the code step by step. This is step over means it is end of step by step running program. Okay, or here once we have started this debug, we can click the stop also. Once we click on the stop, it will be stopping the debug. Okay, so what we want to do is here, we want to run it step by step. So for the step by step run, this is the shortcut. This shortcut is available here also. This is the shortcut, okay, for step by step. So we will be clicking here. Once we click one time, it will be running the first statement. First statement is moving 10h into a. So you can just see. So once it has run it, you can see the content. So it will be once we are running, it will be going further. So green indicates at this point location the program is execution is there. At this location the program is execution is there. So now once we next click, now it is going to run like the second. It now the second at this second location, this execution is there basically. Okay, so next we click next, it will be moving further to this location, and we do the next, it will be ending basically. So we need to check what is the content. Yes, okay. So is there some error? So here also, like what is the location of different ports, it is basically given here. The c dot c semi c colon, this location indicates like this is the location where the codes are written. So just a minute, we will be like stopping this debug and check like why it is showing us the error. Once we have, so this is the way we can build, or again we want to rebuild, then we will be clicking this one. So once we have rebuild, zero warning and no errors, we will go with debug, then okay, no problem. So now if we want to run it, we need to click on this, the first step. It is not changing the content. Stop, start, run it. Okay, let me change this to backslash. So in some codes basically it takes this as the comment, or sometimes it takes in different formats, it will be taking like now we will be starting. Okay, before that we need to build first. Okay, if we want to run it step by step, step pointer, why it is not changing the content of A and B. Okay, so basically we are having the codes are same. Okay, we will write some other codes like basic. Okay, demo.asm. Some more functions are like we can go here. Okay, so this is the frequency we use. So whatever the device frequency is there, so device frequency in case of 8051 is that is around 11.0598 megahertz. So we will be making it like 12 megahertz also. And then in the output we will be clicking on to create hex file. Okay, so these are like, once we run the code, if it is running perfectly, it need to be creating a hex file, and that hex file need to be burned on the microcontroller. So that check is also required sometimes. So we will be building it. So here you can see creating hex file. It is done creating hex file. We need to check the outputs. So why it is not showing? It is move a comma b. Yes, and origin, everything is fine. So why it is not? Okay. In case of the memory, don't know if there is some. Okay. So let me open another. Let me open another project. So basically, we have just you need to close this project. Basically, we are going to close it and open the new project. So new project is like we have already done the testing. So just test.asm. So in that case, okay. So the error is like we need to include this has. Has will be indicating like it is a number. So I forgot to add this. So that's why it is going to give the error. So we'll be closing this project. Open a new one. And in demo, we need to open the project. So you need to click here, all files. Projects files are this. So you need to create, open it. Okay. So this you need to close. Whenever you are going to give the value, you need to give in terms of like with the hash. So you need to give this hash file. When we are going to give the value, you need to include the hash. So I forgot to include that. So once it is saved, you need to build. Once we have built, okay, so whenever there will be an error, it will be showing you out the error also. So you can just see. Okay, so we need to save it and then build. So now there is no error. So once we are going to provide the address, basically this is the address, that's why it is has not included. When we are going to provide the data, we need to include the hash. Okay, so hash will be included like this is the data, this indicate the date, this is the data. If it is 00h, it will be indicating like this is not a data, this is an address. So we are at the first one, we are going to say like this is at 00 location the program should be starting. So this one is address, so hash is not included. If we want to include a data, we need to give the hash. Okay, so we need to save it. Once we have built, we need to go to run. In case of debug, we need to go to the debug. Once we go to the debug, it will be like that. Now we need to run step by step. So step 1, once we, yes, so once we move to from step 1 to step 2, so the first instruction is executed. So once first instruction is executed, the 10, that is 10 content in hexadecimal, will be saved at A location. So A register is now with 0, it has changed to 10. Next we go to next step. Now the content of B register has been changed to 20H, so 20 in hexadecimal. Next is now we are going to move the content of B to A. So once we want to move the content of B to A, so here again you can just see the content of B will remain same, the content of A has been changed to 20. So now the B value is changed to A. Okay, so this is how we should be moving to execution. Okay, so this is how we should be running. You can just check. Okay, in the move case there will be no change in the status bits basically. Oh yes, this is the parity. This P stands for parity. So if it is 20 is written, so 20 we will be having like it is even parity or odd parity. If it is 1, that means it is in even parity. Even parity means 2 or the number of uh, I think this is the parity that is basically going to give. So parity gives like in, but in case of moving the content, we will not be having the change in the PSW or content. Once we are going to have arithmetic and logical operations, then only it will be changing. So I think, but it was by default 1 only. So this is the basic programs we will be running. So once we have run this content and we have observed it, we will be proceeding with the next example. So just you can stop it. Okay, so now we will see another one, some other project. So just close this project and create another project. So go to project, go to new, and instead of demo, now we need to create a new project. Suppose addition, add a project, we want to have an add. So inside add we need to add the project name. So suppose add is the project name, then we need to give the device. So device will be 8089s 51, you can consider it. Type is no. Once we have created this, you can expand it, it is source file. So for adding to the source file, you can directly go here and add a new item to source file, and from there you need to click on .asm. So either it is .a51 type file, or you can directly click here, or you can separately click a new file and then you can mark it. Okay, you can mark it like .asm file or whatever file you want to have. From there also you can create. So we will be creating a new file and then we will be saving it. Control save, or here you can save it by control save. Okay, so once we control save, you need to select the add project file that we have created. So here we need to give the name. So we will be giving the name add itself. So add.asm, because we are going to write the assembly language code, so we will be providing the extension asm. So this is the basic of the program, basic file, that how we can create. The next we want to see is, suppose in this uh, device there are different ports are defined. So ports, and you can go to the peripherals, there will be ports and peripherals coming out. So once we will be writing the codes, we will go to know. So once we will be writing the program, so like we are providing the some input from a particular port, and then we are going to save it to a particular location. Okay, so we are here provide an input. So starting with, like, we will be writing like org 00h, capital H or small h. Now we want to give the content. So suppose we want to move content to a port 1. This is P1 will be representing a port 1, and the data to P1 should be like, initially we are going to read 0 FFH. Okay, another port is there, suppose P2 is there, another port, and we are going to give this also initializing basically at FF. Okay, now we want to input some, or whatever the input we have initialized, Either we can give the data to this port, or we can manually put the data also. So we will be coming to know. So once we have provided the data, we want to move the data, suppose to a particular register. Suppose move the port A data to port 1 data to A location. Similarly, another instruction is move port uh, this port 2 data to B register. Or what we can do is, yes, suppose we are going to move the content to B register. Now we want to add A comma B. So by a particular port 1 and 2, we are providing two data, and these two data are being added to A. Now we want to move the result into port 3. So port 3, we want to move the result from A location, because the result is stored in A. So we want to move from port A to port 3, and once we have done, we will be ending it. So but we want to, this is the simple program, but we want to continue this. Means once it is uh, showing the result, what we want to do is, we want to further add the, or further repeat, ask the data from the user, and keep on rotating this. Means we want to implement a loop. So for loop, there is a command like sjmp. So sjmp is basically unconditional jump. Here it will be taking a jump, and here a location is there. So here is, suppose a location is there, and we want to take this jump, and here we will be moving this here location this way. That means we will be writing it like that. Just okay. So this is the program we have written. Starting with here, we have started with 00 location, and then move to 0ff. We have moved this content to p1 and p2 port. We have initialized its value. Now we want to move the content or the value of p1 and p2 port to a and b, and then we want to add it. After add, the result is to be stored at p3 location, and once it is saved at p3, we want to again go here and move the content of p1 to here. Okay, so then it will be keep on rotating. So we will save it. Once we have saved it, we need to attach to the source location. So we will be attaching. So add existing file to the source. The existing file did is add, and close it. Now we can expand it. You can see like there is an file added. So again we will save, and then go to project and build. So we will build it because we have added it, we have built it. There is no error. And also we need to do one thing like go to target and options. In that options, because we want to have the output hex file also. So we can provide the, first of all, here we can provide the frequency. So frequency, suppose we are providing approximately 12 megahertz to, because 11.0598 is the megahertz is the frequency of the 8051 microcontroller. So we were going around 12 megahertz we are giving. At the output section, click on this create hex file and click on OK. So now we will build again. So once we build, you can just see creating the hex file from this object and add. So it has created a hex file also. Once we have built it, we need to run it. So for running, we need to go to debug and go to start, click here. So this is about how we should be starting. So now we can just check one by one. So it is like, yes, click on here. Okay, so before that we need to go to peripherals, because into this peripheral we are going to use p1 and p2. So we need to check whether what is the value of p1 and p2. So in input output ports, we can go for different ports. So click on this port. So this is the value of port 1. Again You can go to port 0 and port 1 and port 2 and port 3. So we are going to use port 1 and 2 and 3. So we want, okay, so we don't want port 0 because we have not used. So this is the port. So first code it is run is this one. So all the value is 0 0. Next we will go, this is the value 0 0. So here at p1 we are going to move to here. So initially we have initialized p1 and p2 as this value. We can initialize the p1 and p2 value by changing the bits here also. So we can change the bits. So suppose we want to have the value like this is the value of 9. So suppose we want to give the p1 value as 9 and p2 value as, suppose, 1. Suppose p2 value we want to have a 1. So we can change the value of p1 and p2 directly from manually here, and then against we will be changing. So once we are running this program, we have run, then p1 content will be moved to a. So p1 content we have made it 9, so 9 is moved to a. Next we will run it. Now p2 content that is given as 1, so 1 is moved to b. Now it is going to add a and b. Once it is adding a and b, so 9 and 1 is added and it will be a. 10 is in hexadecimal, it is a. So a will be stored at a location, and then we will be moving this a content to p3 port. So this is the p3 port. Initially it is f value is there, all the 111 are there. So once we run it, it just see the result of p3 port. Once we run it, you can just see this is uh, 0a, has it has changed to 0a. Okay, now it will again, we will be jumping here. So once we click again next, it will again go to here only. So once it is here, it is asking for again the p1 value. So suppose p1 value we are providing is like this. So 0d we are providing the value of, in hexadecimal it is 0d, or we can just check it. So suppose 5 is the value we are providing at p1. So we can click next. We can see this a value is 5 now. Again we want to check the value. Suppose we are providing 3 value for port 2, then run it. It will be running, then it will be moving further. The b value is 3 now. So once the b value is 3, now it will be adding the 5 and 3 will be added and result will be 8. 8 will be now moved to port 3. So once we click again, it will be moving the 8 value. So this is 8 value moved to port 3. Again it will be jumping. Okay, so this is how we can see the result. Okay, and also with respect to the ports, and also with respect to like this, there are different peripherals. So even some interrupts we can handle. Serial ports are there. Timers we can consider. There is 0 1 and watchdog timers are there. So in case of this device, it supports basically. So once we want to stop the running, we can click on stop debugging. Okay, so now this is all about the basics of assembly language programming. So I hope you have got the point. So the next point we will be seeing into the next class. Okay, so thank you. I hope you have got the point. Okay.